on earthquakes, so I'm going to tell you.
Hello everyone, welcome to our video lesson on earthquakes. Many things occur during an earthquake and consist of many factors. Earthquakes are graphed on an epicenter. An epicenter is where earthquakes start. Waves from an earthquake are intense and cause the most damage in the epicenter. Below the epicenter there is a focus. A focus is the point in an earthquake where the rocks start to fracture. The magnitude of an earthquake is based on a scale of 10. Seismographs are used to record the magnitude of any earthquake that occurs. There is also earthquake intensity, which bases the destruction of earthquakes on a Mercalli scale. Since seismographs are used to record an earthquake's magnitude, shake maps use that information to demonstrate the areas with intense shaking. Earthquakes occur along faults. Faults are plate boundaries that contain broken and deranged rocks. The ruptures of these rocks releases seismic waves, which is stored energy.
Hi, my name is Gabriel Lopez, and we are here.
The seismic attenuation describes the energy loss by seismic waves. As these waves start moving away, they start getting smaller. Seismic waves are waves of energy caused by the breaking of rock or an explosion. These waves are recorded on seismographs. Some of them move faster through consolidated bedrocks. Others move slower through unconsolidated sediment and through unconsolidated materials with high water content. Henry Fielding, a professor of geology, concluded that earthquakes must have involved an elastic rebound of previously stored elastic stress. The elastic strain energy builds up their edges in the rocks along fault planes. There can be three kinds of different stress. The first one is tensional stress, which stretches rock. The second one is compressional stress, which squeezes rock. And lastly, shear stress, which results in slippage and translation. A subduction zone is the biggest crash seen on Earth. Subduction zones were first located in the 1960s. Usually, subduction zones happen where planes collide. It is important to understand how subduction zones work because it helps scientists identify areas of high volcanic and seismic activities.
Dip-slip fault is a vertical movement of a fault. The dip-slip fault can occur either as a reverse or a normal fault. A normal fault is a hanging wall that slides in a down motion relatively to the foot wall. Now, the reverse fault is also known as a thrust. The hanging wall moves upwards towards the foot wall. Therefore, when the reverse fault moves, it creates a shortage in the crust, and the dip of this fault is set at no more of a 45-degree angle. Within the thrust fault, it has the same motion as the reverse, even though the thrust fault plane is a 45-degree or less angle, which creates ramps, flats, fault bends, also known as a hanging wall, a footwall fault. Another fault type is a strike slip, which causes the crust to move horizontally parallel to the fault trace. An example of this strike slip would be the San Andreas Fault, which is a sliding boundary between the Pacific Plate and the Northern American Plate. It slices California into two, from Cape Mendocino to the Mexican border. The largest cities that are within this fault line are San Diego and Los Angeles, which is determined to be located in the Pacific Plate. Now, going up to the Northern Plate, these cities are in the San Andreas Fault: San Francisco, Sacramento, and Sierra Nevada.
Hello everyone, my name is Jonathan Rojas and I will be talking about the Earth's internal structure. Earth is composed of layers. The outermost layer of the Earth is called the Earth's crust. The Earth's crust is comprised of large plates of land. These plates are called plate tectonics and they move. As a result of that, we sometimes do happen to get tragical earthquakes. The depth of the oceanic crust is 5 to 10 kilometers deep, and the continental crust is said to be 30 to 50 kilometers deep. But what is the oceanic and continental crust? The continental crust is all the dry land and much thicker than that of the oceanic crust, which is all underwater. Next, following below the Earth's crust is the Earth's mantle. The mantle composes 85% of the Earth's volume, and because of that, has two layers within itself, the upper and lower mantle. The upper mantle is low pressurized and cooler, making everything within that section a solid, versus the lower mantle, which is more pressurized and hotter, making everything liquid. Temperatures range from 500 to 900 Celsius in the upper mantle to that of the lower mantle, which is said to be at a whopping 4,000 Celsius. Finally, we get into the Earth's core, consisting of the inner and outer core. The outer layer is a liquid layer of about 2,260 kilometers in thickness. The depth of the outer layer is 2,890 kilometers beneath the Earth's surface. The inner layer is a solid sphere. That solid sphere is about 1,215 kilometers in radius. That's pretty big and round, and that's roughly, I want to say, about 70% of the moon, just to give you an idea of how big the core might be, the inner core, of course. Little is known about the Earth's core because of the extreme depths it is in, but scientists believe that the temperature of the Earth's core, of course, ranges from a staggering 6,000 Celsius to 10,800 Celsius.
Hi, my name is Lindsay Tejeda.
Earthquakes are sudden rolling or shaking events caused by movements under the Earth's surface. Earthquakes happen along cracks in the Earth's surface called fault lines and can be felt over large areas, although they usually last less than 1 minute. Earthquakes cannot be predicted, although scientists are working on it. Precautions. Look around places where you spend time. Identify safe places such as under a sturdy piece of furniture or against an interior wall in your home, office, or school, so that when the shaking starts, you drop to the ground, cover your head and neck with your arms, and if a safer place is nearby, crawl to it and hold on. Practice how to drop, cover, and hold on. To react quickly, you must practice often. You may only have seconds to protect yourself in an earthquake. Before an earthquake occurs, secure items that could fall and cause injuries. An example, bookshelves, mirrors, and light fixtures. Store critical supplies, such as water, medication, and documents. Plan how you will communicate with family members, including multiple methods by making a family emergency communication plan. When choosing your home or business, check if the building is earthquake resistant per local building codes. Earthquake and structures. Every year, several earthquakes occur on planet Earth with severe loss of human lives. During an earthquake, most of us already experience the vibrations at the Earth's surface due to the propagation of the seismic waves along the crust. The main question we intend to answer with this project is, how do seismic vibrations affect the civil engineering structure like bridges, dams, or the buildings? After the massive earthquake near Japan, one wonders if it's possible to build an earthquake-proof building. The answer is yes and no. There are, of course, engineering techniques that can be used to create a very sound structure that will endure a modest or even strong quake. However, during a very strong earthquake, even the best engineered buildings may suffer severe damage. Engineers design buildings to withstand as much sideways motion as possible in order to minimize damage to the structure and give the occupants time to get out safely.